All right, so this should be an easy test. We probably don't even need to review it. But I suppose we will. All right, number 1 says you should be able to find and give examples of biotic and abiotic factors. So, what?
No.
Abiotic is not life.
Not living things. Okay, so here's the thing: something that used to be dead, or sorry, something that used to be alive would still be a biotic factor. Okay, when we talk about abiotic factors, we're talking about things that were never living. So,
Like
rocks, air, sunlight, temperature. All of those would be abiotic factors, things that affect organisms but are not alive.
So, like the dead carcass would be a biotic,
Yes.
but that wouldn't really affect it very much, would it?
Well, it depends. If the organism eats dead stuff, then it obviously is going to. If it is going to give a place for some other organism to live, that organism lives off. I mean, it just depends on the interaction. Yes, Zoe? Yes. Okay. So, test question. On test, I may ask, would a piece of grass be considered an abiotic or a biotic factor? Okay. Pretty simple. Number 2, you should be able to find, compare, and contrast populations, habitats, ecosystems, niches, communities, and biomes. Now, I know we probably didn't talk about niches as much as we should have the other day, so we'll talk about that here. We should have an idea of some of this stuff. Okay? First of all, population and community. What is the difference between a population and a community? It's like the first thing that we learned. Bryce?
Okay, species or population is one species, and we get a community of a lot of species.
Right. So population is a single species. A community is basically all the populations. Okay, so we use those differently in biology than we do when we're referring to humans. I mean, when we talk about population and community, I mean, we almost use those interchangeably.
Well, population would be like who's living at your house, and the community would be like who's living
Right. If we wanted to apply it more specifically, that would make a little more sense.
I agree entirely, right?
Okay. What would be a habitat then?
A place.
Okay. So where the organisms live.
Is that like where one species lives?
Yes. Yeah. When we talk about a habitat, we're talking about a single species. Yes. Okay. Now an ecosystem, well actually let's move on and do niche first. So a niche is different than a habitat because a niche is more like the lifestyle that organism employs. So where we talked about the birds and how they had different niches in the tree, they had different places where they hunted for insects, and because those niches didn't overlap, there was less competition. The lifestyle of the organism. Yeah, we can think of habitat as being kind of like a dress, and niche is more like lifestyle.
So like what's on the dress?
What's that?
A dress.
Yeah, not a dress, a dress. Like where you live. Address. Sorry. I guess I don't say that as well as I should.
It's like so
Sorry. Okay. Now an ecosystem It's basically going to be all the habitats in an area. Okay? So, for example, a fish would live in the lake habitat. A skunk would live in the prairie, in the grass, habitat that surrounds the lake. Together, the lake and the grass and everything there would encompass and make a ecosystem. That's it. I mean, there's interaction between all of those things. Okay? So you can kind of think as habitats being more like, if we were to apply to humans, the houses, the ecosystem would be more like the entire town or the area where all the houses are. Okay? And then a biome is basically just a generalized type of ecosystem. So if we talk about tundra, that's a biome because it's an ecosystem that we see in different places that has very similar components in those areas. So biomes are kind of like specific types of ecosystems. So we can generalize because they have very similar situations. Generalize the makeup of them. Okay, so there's a few terms there that there's some subtle differences between. Hopefully that makes sense. Any questions there before we move on?
I don't really understand niche, but still. I don't either.
So,
It's how they live.
yeah, it's how they live. So, the fact that not only that an owl is going to hunt at night, but it's going to hunt certain types of organisms in a certain way, that would be the niche. How it goes through its lifestyle to get what it needs. Where it lives, as far as what kind of trees does it make its nest in, that would be its niche. So it's basically
It's a pretty broad thing of study.
well, it's the specific things that specific organism is going to use to go through its life. Okay? Yes?
How do you sort the ecosystem?
All habitats.
All habitats. All right.
Yeah, an ecosystem is like all the habitats in an area.
Have the internet.
Well, okay, there is a reason I am recording this, so I don't have to repeat myself 8 times.
Well, you already know, right?
Biome is a generalized, specific type of ecosystem. So, tundra.
I even Googled it to try that.
Okay, so like tundra, right? That's an ecosystem, but the name tundra and the fact that it's a biome refers to when we talk about tundra, we don't have to know exactly where we're talking about. We know there are certain features that fit into that ecosystem. It's a specific type of ecosystem. Okay?
So
That's
we
what
like
that is. About the different biomes, yeah, we'll talk about that. Okay, number 3 says describe biodiversity and how predation affects it. So biodiversity, remember, is different kinds of organisms. The easiest way to measure it is the number of different species that live in an area. So places that have lots of different species have a high biodiversity. Places that have very few have a low biodiversity. Remember, it's not total numbers of organisms, right? You can have 1 million buffalo, that's one species. You can have 10 chinchillas and 10 octopi. I don't know, that would make any sense.
Yeah, no.
Those are 2 species that would have higher biodiversity because there's more different types.
So what you're saying is like a farm that has chickens, cats, dogs, fish, and like a herd where there's like many cows. The farm would have higher.
Right. Over time, farms have become less biodiverse. Most farmers raise 2 or 3 crops. If they have animals, it's like one species. In 100 years ago, there was a lot more biodiversity. standpoint. Okay, how does predation affect biodiversity? Why would it increase it if these things are eating other stuff?
Because other organisms
Okay, it reduces competition. Less competition means that there are more types of organisms that are able to find resources. One reason. The other thing we talked about as far as creation goes.
It changes genes.
It does. Specifically, what types of genes is it going to remove? Bad ones, right? It's going to get rid of the ones that are more likely to be diseased and weak and all that kind of stuff. Predators and I think the easiest catch they can get. Okay, we're going to keep moving here. There's a few things to get through. Primary succession and secondary succession. Remember, succession in both cases is where you have a change in the types of organisms that live in an area over generations. An example would be going from like grasslands to shrubs to coniferous type trees to hardwood type trees, all in the same area over a bunch of different years. So what would the difference between primary and secondary succession?
Primary when nothing's ever lived there before.
Right. Primary is when nothing has ever lived there before, ever. Remember, can't be a little get confused about this. If a volcano comes through and makes new ground, even if it covered up the forest, we would still say that's primary succession. It's not where the stuff was growing.
What's another example?
Glacier. If a glacier comes through and over a few 100,000 years shears off everything and completely disrupts the ground, there's no soil there.
And then secondary would be like if weeds start growing.
Right. Forest fire comes through and burns stuff down and that goes. So I mean, really, the main difference, if you think about it, is just secondary succession happens where there's already soil. Okay, number 5 says describe the energy flow through trophic levels in the 10% law. That's really review. Remember, every time an organism eats something, it only uses 10% of that energy. The other 90% is lost as heat.
Trophic levels there?
Yeah, one organism eats another, and another organism eats that. Those are trophic levels.
Good to know about
Biomagnification, yeah. That's on that. Specifically farther down. Okay, number 6, you should be able to categorize different organisms based on how they get their food. So, you should know, this is review, so everybody should know this already, autotrophs and heterotrophs. But under heterotrophs, we should also know carnivores, herbivores, omnivores, and detritivores. What do detritivores eat?
dead things.
Decaying things.
Wolverines are bats.
Yes, there are chemoautotrophs. I didn't go into the autotroph. I won't ask a question about that on the test, but that is something you should already know. Okay? Number 7 says you should describe some of the different cycles that are important to biological life, including the water, the nitrogen, carbon, and the phosphorus cycles. Now listen, I'm not going to have you draw a detailed carbon cycle or a detailed nitrogen cycle, but you should know a few of the things that happen. Specifically, you definitely need to know how we get those different things. But it's pretty simple, right? How do we get the nitrogen that we need in our bodies? We eat stuff. How do we get the carbon that we need in our bodies? We eat stuff. How do we get the phosphorus that we need in our bodies? We eat stuff. In all of those cases, the only way we get them into us is by eating stuff. Once we've had it in our bodies, how does it get back into the environment? We die. Some of it may come out as in the form of waste, but the majority of it we die, and it gets recycled.
And the phosphate ones, that takes a long time. The rock, is that the rock one?
Yeah, I'm getting to that. Okay. The one thing that don't forget about is in the carbon cycle, we do breathe out carbon dioxide. Now, a lot of carbon does get returned to the environment when we die and decay, but we do give some of that back in the form of cellular respiration.
I think
All a casket really does is delay the process. Eventually, it's going to break down.
yeah, but it won't like go back. Like a big.
All that stuff will break down eventually. I mean, you might delay it even if you put a concrete vault around it. You might delay it a few million years, but it's got to get back to it eventually. It's a lot better just to chuck your body in the ground.
Oh God.
It's natural.
Is that gonna happen to you? Or are they just gonna be like?
Yes, I'm actually setting up things so that when I die, they will dig a hole in the 40 behind my house and throw me in.
What?
It's natural.
You can live in your house.
Okay, listen. The other things that we need to know a little bit about, though, is how these things get into plants. Okay? That's where we have to be careful. Carbon, how does that get into plants? They take it in through the air. Carbon dioxide. I mean, water, I'm sure you know water, right? It
We're not
comes
gonna
in
have to
through
draw
the
the
roots.
water cycle, are we?
Not that specifically. Okay? Nitrogen. How do plants get that in?
It's by bacteria.
Right. The nitrogen-fixing bacteria turn it into a form that they can get through their roots.
Should I study?
What about phosphorus?
Rock.
Rocks break down, and then the plants are able to absorb it. So, the phosphorus and the nitrogen, as far as the plants are concerned, both come from the soil. But this has to come from broken down rocks. This comes from the air, but the bacteria have to change it. Okay? All right, number 8, coevolution. Coevolution is just when two organisms evolve together because they are involved in a symbiotic relationship. And this is why I kind of feel like predation should be described there, because predator and prey are going to evolve together too. They're going to go through coevolution. When you have a prey organism that changes to defend itself in some way, well then that predator population, if they don't change, they're probably going to die out. So you're going to have coevolution there. There's going to be a selection for the organisms, the predator organisms that are still able to catch and eat those prey organisms, even if they have those better defenses. So coevolution is just two organisms that have some sort of interaction, whether it's mutualism, commensalism, parasitism, or predation, and when one organism changes, the other one changes to adapt to that. Again, that takes populations over generations, but we see the changes in both the organisms. That's coevolution. Okay, number 9, symbiosis. Of course, is just a vague term that says living together, two organisms have an interaction. But we talked about the specific cases: mutualism, commensalism, and parasitism. If I give you a situation, you should be able to tell me whether it's mutualism, commensalism, or parasitism. So remember, you're going to look at both organisms and go, okay, I mean, in every case, one organism is going to gain, right? So this organism is going to gain, what about this other organism? Does it gain 2? Mutualism. Does it lose? Parasitism. Does it not care? Commensalism. Should be too hard. Okay, number 10, you should be able to describe competition and how organisms choose their niches to limit competition. So we talked about this briefly when we looked at the birds. We're going to have organisms that are vying for the same resources. So the whole choosing their niches to limit competition, they're going to maybe, like the birds did, pick different places in the tree to feed so that they don't have direct competition. You could have 2 organisms that maybe eat the same things, but one hunts during the day and one hunts at night. That would limit competition because they're not trying to catch the things at the exact same times. It's going to be an evolutionary pressure in that way to cause coevolution so that they don't compete, because that's going to make them able to both exist and pass their genes on. Okay, and then number 11, describe the main differences between the different types of biomes and be able to recognize the different types. So the main differences, what are the 2 main things that go into what kind of biomes that we're going to be talking about? Temperature and rainfall. Those are the things that affect the type of biomes that we see in places in the earth. On the earth. Okay? But you also have to have at least a general understanding of the differences between the different biomes. So if I describe a biome that has lots of trees, it has moderate rainfall, and it's fairly warm in the summertime, but it's cool in the wintertime, that would be a temperate forest. Okay? So those ones that we talked about, temperate forest, tropical rainforest, tundra, taiga, desert, grasslands, ice, yeah.
Taiga is where you find grass.
Polar ice caps. So yeah, taiga, remember, there are coniferous trees, but not hardwood trees. It's cold, it's not quite the tundra though, so trees are able to grow. In the tundra, no trees at all. There's permafrost. No, those. Oh, savanna is the one that I forgot. So there will be some descriptions on there. You have to tell me what type of biome I'm talking about.
Send the link to this.
I do what?
Send the link.
Send the link? I think I'm all on the webpage.
What?
They are all linked on the webpage.
Oh.